In this video lesson, we're going to take a look at density and look at some practice problems. Density is simply a measure of how much stuff or how much matter is in a certain amount of space. A way of writing this is density is equal to mass divided by volume. If there's a tiny amount of mass and a large amount of volume, we would say that it is a low density. However, if there's a lot of mass and a tiny volume, we would say it has a high density. Now, sometimes you're not going to be solving for density, but you're going to be solving for mass or volume. And so you'll need to be able to rewrite the equation quickly and easily in order to solve for this. I like to use the pyramid that's found on the right-hand side of the screen. DMV will help us to solve for the unknown given a mass, a volume, or a density. Here's how you use it. What you do is you cover the part of the pyramid that you want to solve for. So for example, if I want to solve for density, I would just cover the D, and therefore the equation becomes mass over volume. If I want to solve for mass, the equation becomes density times volume. And lastly, if I want to solve for volume, the equation becomes mass divided by density. So the equation can be written very easily so long as we use the pyramid. Now, there are three states of matter in chemistry that we'll be dealing with: solids, liquids, and gases. In chemistry, the density is measured in grams per milliliter typically for liquids, or grams per centimeter cubed for solids. Remember, it's important to note that a milliliter is equal to a centimeter cubed, and therefore it's very easy to transfer back and forth between densities of liquids and density of solids. When we get to the unit on gases, you'll notice that densities are written in not grams per milliliter, but grams per liter instead. The reason for this is because gases take up a lot more space than they would in the solid or the liquid phase. Density is, let's start taking a look at some examples. In this first problem, we'll be solving for a mass. The question says, a sample of pure aluminum has a density of 2.70 grams per milliliter. If a cube of aluminum has a length of 2.0 centimeters on each side, how much mass will it have? Alright, first thing I'm going to do is I'm going to draw a picture so we can visualize what's going on here. So I have a cube of aluminum, and we're told that it measures 2.0 centimeters on one side. Since I know that a cube is the same length, width, and height, I can find the volume of this cube by simply doing length times width times height. In other words, 2.0 centimeters cubed. The answer to that is going to be 8.0 centimeters cubed. 2 times 2 times 2. Alright, now that I have the volume, I can solve for the mass. The density equation is D equals m over v, but we're solving for mass. And so mass, using my pyramid, would be equal to volume times density. Let me rewrite that. There we go. So, to solve for the mass, we simply have to take the volume and times it by the density. So, I'm going to do this right below. Mass is equal to, I just found out that the volume is 8.0 centimeters cubed. The density of the object is 2.70. Now you'll notice it was 2.70 grams per milliliter. Remember, this is the same thing as grams per centimeter cubed, since a milliliter and a centimeter are equal. When I multiply through, the centimeters will cancel out, and I'll be left with my mass in grams. So I times 8.0 times 2.70, and I end up getting 21.6. Since I multiplied, I need to make sure my answer is in lowest sig figs. 8.0 is 2 sig figs, and 2.70 is 3. So I'm going to round my answer to 2 sig figs, but I need to make sure I round up. So 22 grams would be the mass of the aluminum cube. Let's take a look at another example. An object with a mass of 0.0675 kilograms is dropped into a graduated cylinder where the water level is initially at 15.5 milliliters. What would the final water level be if the density of the object is 10.6 grams per centimeter cubed? Let's first draw a picture so we understand what's going on. We have a graduated cylinder, and we're told that the original liquid level is at 15.5 milliliters. Now, When I drop an object into the water, this will raise the water level up to some new volume. The question is, what is this final water level? All right, what else do I know about this object? Well, the object that was dropped in has a mass of 0.0675 kilograms, and it has a density of 10.6 grams per centimeter cubed. All right. First thing to notice is that the units for mass and the units for density are not the same. The first thing I have to do is I have to take my mass, which is in kilograms, and I have to convert that into grams. This is a simple metric conversion. Kilograms is 3 spaces to the left of the gram, or in other words, there's 1,000 grams in 1 kilogram. The metric conversion would be simply to move the decimal 3 places to the right, and so that would make my mass now 67.5 grams. Now that I have my mass and my density, I can solve for volume. Taking the original density equation of density equals mass over volume, I'm going to rewrite the equation to solve for V. So volume is equal to mass divided by density. Now that I have that, I can solve for what my volume will be. The mass is 67.5 grams, and the density is 10.6 grams per centimeter cubed. When I divide those two numbers, the grams will cancel out, and I'll be left with my answer in centimeters cubed. Move all this. There we go. That was a little weird. All right. So what would my volume be? Well, 67.5 divided by 10.6 is going to give me the answer of 6.3679. Now I'm writing all the digits out because this is not my final answer. However, since I'm dividing, I would need to do lowest number of significant figures. The lowest number of significant figures out of 67.5 and 10.6 is 3. So what I'm going to do is I'm going to draw a bar over the third significant digit in my answer. That'll remind me that when I get my final answer, that's the number of sig figs that's there. All right, now what does this volume tell me? This volume tells me that this is the volume that the block of the object takes up. When you drop an object into a graduated cylinder filled with water, it's going to displace a volume equal to the volume of the object. So this change in volume from the initial water level to the final water level is what this volume represents here. Now, what's the units on that volume that I just solved for? The units of that is centimeters cubed from up here. But remember, centimeters cubed is equal to milliliters, so I can just replace the unit like that. And so, if the original water level was 15.5 milliliters, and the water level changed by 6.3679 milliliters, the answer to that addition is going to give me the new water level. So 15.5 plus 6.3679 is equal to 21.8679 milliliters. Since I'm adding here, I need to do lowest number of decimal places. In the first number on the top, it has 1 decimal place. And remember, the bar should be over the 6 like it was over here. And so in the bottom number, that's 2 decimal places. So the top number limits what my number of significant figures would have to be. And so my final answer with correct significant figures would end up being 21.9 milliliters. This would be the new water level once the object was added to the graduated cylinder. All right, let's do one. This problem is very similar to a problem you might see in homework. So let's look at this one. The question says, what is the mass in kilograms of a cube that measures 0.87 meters on one side and has a density of 12.1 grams per centimeter cubed? All right, so real quickly, I'm going to draw out my cube so I can visualize what's going on here. All right, I'm told that this cube measures 0.87 meters on one side. So we need to first find the volume of this cube. Now right away I know that this meter is going to have to turn into centimeters. And so before I do any multiplying, let's convert. 0.87 meters is the same thing as 87 centimeters. Now that I know how many centimeters it is on one side, I'm going to do 87 centimeters times 87 centimeters times 87 centimeters in order to get what my volume is. In other words, I'm cubing 87. So if I cube the number 87, I'm going to end up getting 658,503 centimeters cubed as my volume. Now, this is not my final answer, but I don't want to round this to sig figs yet because this is not where I'm at. So, real quickly, I'm just going to draw a bar over the 5, indicating that that is the last significant digit, because 87 is 2 sig figs. Now that I know my volume, I'm going to plug it into my equation. Remember, density equals mass over volume. But if I'm asked to solve for mass, that's going to be density times volume. So, my density of the object is 12.1 grams per centimeter cubed, and my volume is the 658,503. Let me give myself some more space here. There we go. Centimeters cubed. When I multiply those together, the centimeters cubed will cancel out. So 12.1 times 658,503 is going to give me my mass as 7,967,886.3. The centimeters cubed canceled out, and that is in grams. Now, taking a look at my two numbers that I multiplied, 12.1 is 3 sig figs. And remember, 658,503 technically had 2 sig figs because the bar was over the 5. So I should be at 2 sig figs here. However, I'm not going to do sig figs quite yet because I have one more step to go. My answer is in grams, but the problem is asking for my answer in kilograms. So to get from grams to kilograms, I need to use a conversion factor for metric system. Remember, to go from grams to kilograms, for every 1 kilogram, there is 1,000 grams. In other words, we're going to divide by 1,000. So if I divide by 1,000, I end up getting the answer is 7,967.88. Now, this is my answer, but I need to get it in correct significant figures. From looking up here, compare 3 sig figs compared to 2, 2 sig figs is my answer. Now, here's the tricky part. How am I going to round 7,967.88 to get 2 sig figs? Because if I round it to 7,900, this isn't very accurate because technically I should have been rounding up. But if I round it to 8,000, that's only 1 sig fig. So how do I do 2 significant figures with a number like this? Well, there's 2 ways you can do it. The first way is because all of these are zeros right here at the end, you can simply put a bar over the last significant digit. So this would be one way to show the answer. 8,000 with a bar over the 0 indicates that this is 2 significant figures. This method only works for zeros. For example, if I was looking at the original answer up here at the top, it would not be appropriate to simply put a bar over the 9. That's just being lazy. The second way, and I think it's the more preferred way, is to put this number into scientific notation. And so, 8,000 is the same thing as doing 8.0 times 10 to the third kilograms. Both methods are correct in showing the mass with 2 significant figures.